Here we will continue the questions. That is question number 4. Here is the question. Young modulus of steel, that is y equals to 19 into 10 to the power 10 Newton per meter square, expressed in dynamic. Y equals to 1 equal to how many dyne per centimeter square, where dy and dyne is the CGS unit of force. So this will be information. So let us move to this. So the SI unit of the Young modulus is Newton per meter square. So dimension of y equals to F by L square, that is force by distance square. So mlt minus 2 by L square, that is ml minus 1t minus 2. So will be so n by 2 is the SI unit. So 1 n by Newton by meter square equals to 1 kg per 1 meter minus 1 per second minus 2. Since 1 Newton equals to 1 kg meter per second square, and here is divided by meter square, so this will be cancelled out and negative sign will be above. And 1 dyne by centimeter square, 1 dyne is the CGS unit, so 1 gram 1 centimeter minus 1 and 1 second minus 2. So dividing the both the equation with the previous one, 1 Newton per meter square by 1 dyne by centimeter square equals to 1 kg by 1 gram and 1 meter by 1 centimeter minus 1 and 1 second by 1 second minus 2. So converting the above units into gram, CGS unit, so 1000 grams, this will be meter, so converted into centimeter, then 100, so 100 power minus 1 by equals to 1 by 100 into 1, so 1 to 1 2, so 10 dyne per centimeter square 1 Newton per meter square equals to, so we can say that 19 into 10 to the power 10 Newton per meter square equals to 19 into 10 to the power 11 dyne by centimeter square. Now we will move to the question number 5. The question is the velocity and the time of force, the velocity, time and the force are chosen as the basic quantities. Now find the dimension of mass, that is what is dimension of mass. So we have to find just the dimension of mass by taking the basic units, that is v, t and velocity, time and force. So we know that force equals to mass into acceleration, so mass equals to force by acceleration, therefore mass dimension equals to force dimension F by acceleration is v by t minus 1. So it will be in terms of FVT, F v1 minus 1 t minus t1, v t and v minus 1, or we can write it F t v minus 1, that is the mass dimension of mass. Now the sixth question is test dimensionally that the equation v square equals to u square plus 2as may be correct. For proving that, we may either prove that this equals to this, LHS equals to RHS, so we can say that, or we can prove that these individual units are equal. So v square equals to LT minus L square t minus 2, u square equals to L square t minus 2 as velocity, and 2as ax equals to 2 into 2 has no dimension, so it will be no dimension. Acceleration is vt minus 1 minus 2 and lt minus 2, and x is the length, so l is square t minus 2. Since both the values or both the terms of this equation are equal, so the equation may be correct. Now we will move to the seventh question. The question is that the distance covered by the particle in time t is given by, that is where x is the time is the distance and bt plus ct square plus dt cube. Find the dimensions of a, b, c and d. First of all we have to find this. So we know that there are 5 terms a, b, c and d and x. All of them should have the same dimension. So since x equals to length, so each of the remaining 4 must be have the dimension of length. So a equals to x का dimension यानी कि l, b equals to dimension of t will be minus, so lt minus 1, and c equals to lt minus 2 and d equals to lt minus 3, as bt dimensionally will be l, as all the terms are equal. So dimension of b equals to l by dimension of t, that is lt minus 1, like this all the 3 terms. Now question number 8. The centripetal force is of the form, that is we have to take it F is equals to ma vp and rc. Find the value of a, b and c. So we can equate this by putting the dimension of f, that is ml t minus 2, and equating the dimensions. The dimension of v, that is velocity, will be lt minus 1 ka power b, and r is the distance, so l ka power c. So we can say that mlt minus 2 is equals to ma lb plus c and t minus b. Equating both sides, a equals to 1, l equals to, that is b plus c equals to 1, and minus b equals to minus 2, so b equals to 2, so c equals to 1 minus 2, c equals to minus 1. So values of a equals to 1, b equals to 2 and c equals to minus 1. We will move on to the 9th question, where the question is, when a solid sphere moves through a liquid, the liquid opposes the motion with a force. The magnitude of the force depends on the coefficient of velocity. So we should let the force is directly proportional to coefficient of viscosity of the liquid and the radius r of this power b and the speed of the sphere, that is c. Assuming that the force is proportional to different powers of these quantities, guess a formula for force using the method of dimensions. So we can say that k equals to n with coefficient of viscosity dot rb plus c. So ml t minus 2 is the dimension of force. So dimension of, we will put the dimension. So dimension of viscosity will be ml minus 1 t 1 minus 1, and r is the radius, so length, power a and b, velocity lt minus 1 and c. So mlt minus 2, that is mass into acceleration, m ka power a, l ka power minus a plus b plus c, and t ka power minus a minus c. So equating both sides, a equals to 1 minus a plus b plus c equals to 1, so there will be 1, so b plus c equals to 2, and minus a minus c equals to minus 2a plus c equals to 2. So putting the value a, c equals to 1, so b equals to 2 minus 1, that is b equals to 1. So value of a equals to 1, b equals to 1 and c equals to 1. So formula for the centrifugal force, that is F equals to K, n का power coefficient of viscosity equals power 1, radius का power 1 and velocity का power 1. This will be the required formula. Now move on to the question number 10, and this is the last question of the worked exercise. Here in the question we have to let that the heat produced in the wire is carrying up electric current depends. So heat produced in the wire is directly proportional to I का power a, that is current, depends on current, resistance का power b and the time का power c. Assuming that a dependence is the product of the powers type, guess a equation between these quantities using the dimensional analysis. Is the dimensional formula of resistance, that is R equals to ml square t minus 2 t and I t minus 3 and I minus 2. So and heat is the form of energy. So we can do this by assuming that H equals to itna. So further processing it, we get K, a constant, RB and TC. So we will put the dimension of all. So dimension of heat, we usually know that is ml square t minus 2. Constant will be no dimension. Current dimension will be I ka power a, and this is the resistance. So resistance will be ml square t minus 3 I minus 2 ka power b, and this time ka power c. So ml square t minus 2 equals to m ka power b, l ka power 2b and t ka power minus 3b plus c and I ka power minus 2b plus a. And here we will take I equals to 0, so b equals to 1, equating both sides. 2 equals to 2b, so b equals to 1 here also, and t equals to my 3 plus 3b plus c equals to minus 2, so c will be minus 2 plus 3, that is 1. That's it. So all have the same units except a. Where is the a? Here is the a. So 0 equals to minus 2b plus a, so minus a equals to minus 2b, so a equals to 2. So the required equation of heat equals to K IA RB TC. So K I का पावर 2, A का पावर 2, A के प्लेस पे B 2 और R के प्लेस पे B, that is 1, and T के प्लेस पे C, that is 1. So H equals to K I square RT is the formula, and that's it. Completed the worked out examples, and next day it will be the questions for short answers.